Theory of columns, short versus long. Welcome to Blueprint to Reality, where we break down complex engineering concepts into easy-to-understand lessons. In this episode, we will explore the theory of columns, focusing on the differences between short and long columns, an important consideration in structural design. What is a column? A column is a vertical structural element designed to support loads, typically compressive forces. Columns are found in almost every type of building or structure, from bridges to high-rise buildings. They are designed to carry the weight of the structure above and transfer that load down to the foundation. Short versus long columns. The key distinction in column theory lies in whether a column is considered short or long. This classification depends on the column's height and dimensions relative to its material and cross-sectional shape. 1. Short columns. A column is considered short when its height is small compared to its cross-sectional dimensions. In this case, the column primarily behaves like a simple compressive element. The load applied to the column causes it to shorten proportionally, without any significant bending or buckling. 2. Long columns. A column is considered long when its height is large compared to its cross-sectional dimensions. In this case, the column is more likely to buckle under load rather than simply compress. The buckling behavior becomes critical in the design and analysis of long columns. Why does column length matter? The length of a column is crucial because it determines how the column will behave under compressive load. Short columns, because of their relatively small height, can carry more load without the risk of buckling. However, long columns are more prone to instability and buckling, which can lead to catastrophic failure if not designed properly. The relationship between the column's height and its resistance to buckling is key in understanding why column length matters. What affects the buckling of long columns? Several factors affect the buckling of long columns. 1. Material properties. Stronger materials with higher Young's modulus will resist buckling better. 2. Cross-sectional shape. Columns with larger moments of inertia, such as wide or deep sections, will be less prone to buckling. 3. End conditions. The way the column is supported at both ends plays a significant role. Fixed supports increase the column's ability to resist buckling, while free or pin supports make buckling more likely. 4. Load type. The application of a compressive load at the center of the column can cause buckling to occur more easily in long columns. Real-world applications. The difference between short and long columns is critical in the design of structural elements. For example, in a high-rise building, columns will typically be long and subjected to high compressive loads. In contrast, short columns, like those found in foundations or smaller structures, are more robust and less likely to buckle, allowing engineers to use them in situations where load-bearing capacity is the primary concern, without worrying about buckling failure. Conclusion. In summary, understanding the theory of columns, specifically the difference between short and long columns, is crucial for structural design. While short columns primarily carry compressive loads without the risk of buckling, long columns require careful consideration of their height, material properties, and support conditions to avoid buckling failure. Thank you for tuning in to Blueprint to Reality. If you found this explanation helpful, don't forget to like, share, and subscribe for more civil engineering insights. See you in the next episode.